So today we'll cover section 5.2, some indifference formulas for trigonometric functions. So we're going to go over, just to give you a preview of this lesson, let's go to slide 2, 3, 4. And then look at the bottom of it, and you're going to see these formulas. Those are the first four formulas that we're going to be using. And then at the end of the handout, on the second to last slide or last slide, you can see your other two for tangents, for the sum and difference of the tangent of two angles. And they're right here, so we'll call that 5 and 6. So we're going to go over those. Now, what we're going to be doing with them is pretty simple. We're going to be substituting values. But before we get to that, we're going to do the proof of one of them, and that will be number 2. So we're going to prove that the right side equals the left side, and we will do that geometrically and then with some algebra. Now, I will not test you on, do a proof, but some of you, this is for some of you, or most of you actually, this is not your last math class, and because of that, you might be exposed to proofs, like, for example, in calculus. If you take a class at UTEP during your senior year, or if you go to a university, any other university after high school, you will encounter a professor that will like to do proofs, and you might be tested on that. Or you might study something that requires some knowledge. And in fact, doing proofs, it helps you develop a different part of your brain. So we are going to do it with a good attitude. I don't want to hear any whining. Okay? Yes? Thank you. All right. So first, we're going to be using the distance formula that we learned last semester, section 1.9. So that was something like d equals the square root. And actually, you learned that in elementary, the Pythagorean theorem, right? Or middle school, I don't know when you learned that. A squared plus b squared, the square root of that. So the distance formula, if you know the horizontal distance, then you have to find it, right? So you go like x of 2 minus x of 1 squared, plus, to get b, that is the vertical distance, so you'll get the difference, y sub 2 minus y sub 1, and then we square it. So we're going to use that formula to prove what we have here. Now, when I say we're also going to use geometry, is to describe how these angles are being found, and then we're going to use the coordinates of those points that contain the terminal side of the angle. So first of all, we're talking about the difference between two angles. Yes, we all acknowledge that. So the first angle in question is angle alpha, and that will be from here to the terminal side of the triangle, like the big angle. And then angle beta is going to be this little one here. So if you have the big angle minus the little angle, does it make sense that the angle that we're talking about is this one inside the triangle? Yes, does that make sense geometrically? So the big one, you cut a little piece, so you get what's inside the triangle. This interior angle of the triangle right here. So that one is going to be that difference of alpha minus beta. Now, when you do proofs, you use a lot of things, a lot of tools or tricks, but you also do things for convenience. So for convenience, we have placed that angle inside a unit circle. How do I know it's a unit circle? Because the equation here, okay? The radius is 1. And that's going to come in handy in a minute. In a few minutes, actually. All right, so we're going to find the distance between this point, it's called P, and this point, which is called Q. Right? Now, since this is a unit circle, we could go back to the basics and know that the x-coordinate was given by the cosine, and the y-coordinate was given by the sine. Yes, do you guys remember that? Because the hypotenuse was just one unit circle. So this cosine x, the sine y. And so since we are calculating the distance from one point to the other, it makes sense that we use the distance formula. I do want you to take notes. Yes. Okay. So now we're going to say that this will be x sub 2, y sub 2. This is x sub 1, y sub 1. So instead of writing x sub 2, x sub 1, I'm going to replace with the cosine expressions. So first I will have cosine alpha minus, right here, cosine beta plus, and now I'm going to replace my y's with the sine expressions. So sine alpha from here minus sine beta. And then the square. Yes, are you guys okay with that step? Okay, now the scary part is going to come up, okay? I'm going to expand them, so I'm going to need more room. You'll see why. Okay, so what I have here is a binomial being squared, right? Now, don't write this part, but what I'm going to do, this will be like my scratch work. So I'm multiplying cosine alpha minus cosine beta by itself.
So would it be
going to pass them out?
So would it be cosine beta or alpha squared?
Cosine square alpha. And then if you multiply this one times this one, you will get minus
-2 cosine alpha.
well, yeah, but just wait. And then we'll use the shortcut from after this. This will be the last time I show you the long way, okay? You're too old for that. And then if you multiply this one times this one, you get another one, right? And that's why Andrew was telling us you get two of those. So you guys are at a point in your lives that you need to know that.
What are we doing?
We're expanding this one right here. But this is like the scratch work, okay? So because of that, you have two of those, so those get combined. So that's what I'm going to do there. So that will be cosine square alpha minus 2 cosine alpha cosine beta plus cosine square beta.
And then the other one?
Let's do the other one using the shortcut. So it's going to be the first term square, sine square alpha. And then the term in the middle is the product of the first term times the second term. And then what do we do, Andrew?
What? Oh, you add them together.
So you double, right?
Yes.
So two of them. So -2 sine alpha sine beta. And then sine beta squared, we just put the square right after the sine. Remember that this was just scratch work, guys. So if you copy that, I hope you still have room there.
Is it weird saying your daughter's name in math?
Well, I actually pronounced her name wrong because her name should be, it's with an E, but I do call her and at some point some of my friends thought her name was Alpha, and then like another one thought Karina was Beta. Like, no, like his girlfriend told him, yeah, the other one is Beta. You didn't know? And he believed for like a year. Yes. Antonio was going to be Delta. Yeah. Okay.
Or Theta?
Omega.
Sigma?
Hey, some good ideas for me. All right. Now, oh, yeah. So what happens when you have a, let's say, a cosine square alpha and another one sine square, and not another one, but a sine square alpha. What will that turn into? Do you guys remember me mentioning a lifesaver identity? What is it, Garrison?
These turn to 1.
They turn into 1. Just like that, by magic. Why? Because of, look over there at the board, Pythagorean identity, the OG, original. As long as you have the same angles and you have the cosine and the sine square, you can substitute that with the number 1.
Wow. Wow.
And then can't you do that with cosine squared beta and so?
Thank you. So we do that again.
So it'd be 2.
So it will be another 1. So 1 plus 1. Let's just put 2. So you guys know where those 1s come from, yeah? And 1 plus 1 is 2, yes? Are you guys okay with that?
Yeah.
So 2. Then, well, let's copy the rest. So here, minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. All right. Now we're going to leave this alone for a minute. We're going to come back to it. Now we're going to use the second picture that we have, which is the exact same as the first one, but it's being rotated. It's like if you grab this triangle and you rotated it clockwise so that this side is now on the x-axis. Yes? Does it make sense what happened? Just took the triangle and rotated it. All right? So then, now, since we purposely chose a unit circle, that is why the coordinates of this point are 1, 0. Yeah? So the point that we call point P is actually here now. And because of the unit circle, we could say that the coordinates are 1, 0. Because the radius is 1. Now, the angle inside the circle, here, the one that I colored in green, I mean inside the triangle, this one here, it's still here. Same angle. Right? How do we call that angle? Is the difference between the two, so that was angle alpha minus beta, right? So right there. And then the point is still point Q. However, now we're going to use cosine of alpha minus beta for the x coordinate, and we're going to use sine of alpha minus beta for the y coordinate. Okay? And I'm going to calculate the distance formula again. This one is actually easier. No, don't be scared. I think the scary part is already done. That was the scary part. Okay, so if you are lost, it's okay. It's normal. Because you guys haven't been exposed to proofs that much. And that's why I'm doing it. Okay, so let's see if you guys can help me out with this. So what will be my x sub 2 now?
Cosine alpha minus beta.
Yep, right
Minus
here.
1 squared.
Slow it down. So cosine of the alpha minus beta. And then what you say was x sub 1 minus what?
1.
1. This one right here. We're using distance formula again. This one. And then square, plus. Now we need to take care of the y's. So the y coordinate that we will use, y sub 2, instead of that, we're going to use this that I'm circling. Sine. Minus, what is the y sub 2? 0. And then we'll square. Are you guys okay with that substitution? It just came from here.
Oh.
Okay, so now I'm going to expand that. That one is not as ugly as the other. So here, it will be this term square. So what we square is the cosine. Cosine square of that angle. Yeah, are we okay with that step? Then, according to the shortcut, you have to multiply this term here times -1, and then we double it. So that will be, if you multiply this term times -1, it will just be negative cosine of that angle. We double, so it will be -2 cosine of that same angle. That's it. We don't do anything to the angle. And then we square the -1. What is -1 squared?
1.
Okay. Now right here, we have a 0, so we don't need to worry about it, right? We don't need to square it, so it'll still be 0. So we just need to square this part right here. Plus sine square of that same angle. Okay. Now, is there another Pythagorean identity there? Do we have a sine square and a cosine square of the same angle? Yes. We'll see that.
So would that be 1?
That would be 1.
So it's only the co-functions that can cancel each other out to 1? Or is it just with sine and cosine?
Well, you could actually any variation of the,
Like say if you have
Like over here,
secant and
too.
cosecant,
as long as they are
the same, but like
not the same, but they're variation, like that, like you didn't do any like illegal movements, per se, like a negative or a plus. Yes, you could always replace with 1. Like if you had a cosecant square, is this the one you were saying?
yeah.
Cosecant square of theta minus cotangent square of theta, you could also replace it with a -1.
Wait, why would it be cotangent?
Well,
Wouldn't it
would
be
you
the
write
secant?
this one the other day? I don't remember. It's cotangent because it came here from this ratio, from this quotient identity. Let's get back to this one here. So we had a 1, and then there's another 1 here. You guys see it? Yeah? So 1 plus 1, and then -2 cosine of all of that. I just wrote 1 plus 1. That's all. And then minus this one. That's all I did. What did we do with the ones that I underlined in blue? I replaced them with the number 1, because that's what it's equal to based on the Pythagorean identity. Okay, so then this one is actually, if we add 1 plus 1, you guys should know that, right? It's 2 minus 2 cosine of alpha minus beta. That's it. That's all I've done so far. So now, what I'm going to do is, since the whole time we've been talking about the same segment, PQ, then I can say that both of those not rational, but radical expressions are equal, right? Because it's the same segment. So again, for convenience, I'm going to equal them to each other. The one that we did in with the green marker, and the one that we did with, that I did with the black marker. Okay, no talking, please. That's what I asked. So the square root of 2 minus 2 cosine of alpha minus beta is equal to the other square root, this one here, two minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Okay. Are you guys following what I'm doing? Just equaling one to the other. That's it. Okay. How can I get rid of a square root? Square it. Very good. So we do it to both sides. And of course, that will cancel the square roots, right? So 2 minus 2 cosine of alpha minus beta equals 2 minus 2. Oh, I keep forgetting that. Minus 2 cosine of alpha cosine beta. Minus 2 sine alpha sine beta. Okay. Yes. All right. Now, what happens if I subtract 2 from both sides? You guys know I don't like to do this, but I'm doing it. They cancel, right? So now we have negative 2 cosine of alpha minus beta is equal to negative 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Now, what do they all have in common, left and right? Negative 2. So if we divide everything by negative 2, we could do that, right? Because as long as we do it to the whole equation. By the way, the second slide was if you ran out of room.
Thank you.
Oh, wow.
Thank you.
So negative 2's cancel, and we have cosine alpha minus beta equals negative 2, because they cancel because they equal 1, right? So we have cosine alpha cosine beta, not minus, but what should I have here? Instead of minus, plus, because negative 2 divided by negative 2, plus sine alpha sine beta. Okay, now you guys ready for your surprise?
Yeah.
Yes? Look at the formula on the top of the page inside the box.
It's
Oh my God.
one.
Oh my god.
Yes, that is the same. Now, that is an example of a proof.
Is that it?
Yes. That's just so you know that it is true. Yes. All right. Am I going to test you on that proof? No, I'm not. It was just for your own enjoyment,
Oh.
entertainment.
This is my favorite kind of entertainment.
All right. Next. How can we use it? It's super easy. Find the exact value of 15. Can you guys tell me that without a calculator?
Yes.
Of course. It's
Oh, yeah.
No, wait.
It's over.
Wait, would it be
So-
1/4? 1/4?
No.
9?
1/12?
No. Okay. You know the cosine of 45, right? And you know the cosine of 30, correct? And what do you get?
5/9.
Okay. Stop guessing. What do you get if you subtract 30 from 45?
15.
You get 15, right? So what we're going to do here, instead of the cosine of 15, we're going to say the cosine of 45 degrees minus 30 degrees. So in that case, we're going to use the formula that we just proved, and then that will be cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle.
Wait, Miss, would it be
Well, wait. So let's substitute square root of 2/2, and then tell me, Andrew, what's the cosine of 30?
what? Square root of 3/2.
Very good. What's the sine of 45? Chris?
Oh,
Very good. And Yvette, tell me my favorite sine of 30. Very good. So then if we multiply, right, there's two fractions here, straight across, so square root of 6/4 plus, right here, square root of 2 times 2 is 4. And if you put them under one fraction, it will just be 4 square root of 6 plus the square root of 2. So yes, you can tell the exact value of the cosine of 50. All right, now let's look at example 2. It's kind of like going, well, I'll give you some, do you guys need time to catch up?
Yes.
Okay,
Catch
Just
up?
leave it like that?
that's the answer.
I thought you would divide square root of 3/2 by 2. Because like it's 15. But I got square root of 3, which is not good.
Oh. Now, once you get to this point, guys, you cannot add those numbers, okay? You do not add numbers that are inside a square root. You can multiply them, that's okay, but you cannot add.
So what do you square them? So you know how to square root and do that.
I mean, if it's an equivalent expression, yeah, that's fine. But if you square this, Trisha, it's not just gonna be that square and that one squared. You're also gonna have a term in the middle, which will be twice the product of the square root of 6 times the square root of 2. So it will make it even worse.
Yeah.
So that's not.
Yeah.
You just leave it like that. All right, now the next one is like going backwards. So this formula is the same that I proved to you, but the first angle happens to be 80, and the second angle happens to be 20. What is 80 minus 20?
60.
And do you guys know the cosine of 60?
Yes, we do.
What is
Under?
It's the same as the sine of 30, which
Oh,
is
one
my
half,
favorite. 1/2. That's it.
Right.
Wait, that's it?
Yes, yes.
I am lucky.
Wait, so I have a question. So, for example 1,
Uh-huh.
why did we have to like do that whole thing on the right side, and then for example 2, like we just type it in?
Oh, okay, because we're going, for example, from the formula on the first slide, we're going from here from like left to right. From a difference of 2 angles. And then on example 2, we're going like, if you look at the formula from your first slide, you're going in the opposite direction, from right to left. So then it's like they're giving you the first angle and the second angle. So this will be like alpha and this will be beta. So you just have to figure out which formula they're talking about. In this case, it's the subtraction.
Got it.
Okay, so here we have formulas 1, 2, 3, 4. So we're going to be using those. I'm not going to prove all of them. It was only the second one. So here we're going to verify an identity, your favorites. Yay. So the cosine of the difference of 2 angles is the same formula that we've been using. So it is. By the way, I'm going to let you guys use those formulas on the test. I will give those to you, not because I'm nice, but because...
We need them?
no, you don't need them. You could memorize them. But because they're so similar, and if you just mess up with a little minus or a little plus, like your whole work is gone. So I'm just going to relieve some of your anxiety by giving you those formulas. So what I'm going to do here is prove that the left side will equal the right side, okay? So first, I'm going to use the same formula that we've been using. So that is cosine alpha cosine beta plus the sine of alpha sine beta divided by sine alpha cosine beta. Then after that, I'm going to split the fraction into 2. So each numerator divided by the same denominator. And then second numerator from here divided by the same denominator. And then I know you're starting to see things. What is cosine over sine?
1.
Cotangent. What is cosine of the beta divided by cosine of beta? This is 1. Yes.
Sure.
Now here, what is sine of alpha divided by sine alpha? And what is
Tangent
sine
of
of
beta.
beta or
Jesus.
cosine beta?
That's the only part I know when you're answering it.
And so that's what we needed, right? On the right side?
Yes.
Tangent of alpha plus tangent beta. That's what we were trying to prove. All right. So let's move on.
No.
Okay, we're gonna move on. Now, here, we're talking about the sign of 7 pi over 12, which, we don't know it by memory. We know all the ones with the denominator over 6, denominator 4, denominator 3. I mean, you know them, or you know how to find them, right? If you draw theirs in a circle. However, those we don't, so what we have to use is the subtraction, but before that, let's make sure that it is true. So if I start with like pi over 3 plus pi over 4, and I want to add them, this will be, I want them to have a denominator of 12. Right? And so the first fraction, you know you have to multiply it by 4 over 4.
4 pi
So 4 pi.
plus
And then here we have to multiply by 3 and 3. So that would be 3 pi. And so if you add the numerators, you get 7 pi not over 12, right? So we just did that to confirm that this is true with the given information. So if we want to find the sign of 7 pi over 12, then we will use the sign of pi over 3 plus pi over 4. Now look at your 4 formulas and tell me which one you will use.
So these square root of
By number, by number. 1,
Yeah.
2, 3, 4. Which one?
this is supposed to be 2 over 2 plus.
Number 3? Okay.
3.
Could you tell me how that one starts? Hey, Beth? Of the first angle? And then cosine? Yeah?
No, cosine. Oh, yeah, cosine.
Of the second angle?
What, cosine of the first angle, and then of the second.
Very good. So, you know, you guys need to be very careful when you choose your formula and when you substitute, okay? And when you, especially if it's a plus or a minus, you have to be very careful with that. Okay, so then here we're going to replace the values. So the sign of pi over 3, that's like the sign of 60. What is that? It's not 1/2, it's the other one.
Square root of 3 over 2.
There you go.
Square root
Okay,
of 2
not
over 2.
Andrew. Oh, okay, Andrew. Square root of 2 over 2. And then plus, what is the cosine of pi over 3?
Can I say it? Can you say it?
Sure,
Square root of 3 over
it's wrong.
No, 1/2.
It is 1/2. Well, of course, because now square root of 3 over 2 is 1/2, right? So the cosine of pi over 3 is like the cosine of 60, which is the same of the sine of 30, my favorite. 1/2. You cannot forget my favorite, guys. And then the sine of pi over 4.
Square root of 2 over 2.
Very good. So you guys see, it's very simple to use the formulas, right?
Yeah.
That's what I will test you. Multiply straight across. And that's it.
Really?
I know, we got the same answer, no?
Yeah.
Isn't it weird? What is 7 pi over 12 in radians? I mean in degrees, sorry.
It's somewhere around 270 or 260.
Can someone compute that for me? You could use your calculator. Chris, you have your phone right there. Come on. 7 times 180 divided by 12.
1260.
What about
1260.
Yeah, 2 and 5. Oh, wait.
Over 12? I don't know.
Well, yeah, over 12.
Oh.
Oh, well, it will be 15, isn't it?
Yeah.
No.
Do you,
It was
do you like
105.
15?
It's 105.
This divided by 12 is 105? Aww. Oh, I just thought of something. But isn't it 105? If I ask you guys, what's the reference angle of 105? Think about it.
75? I mean, 85.
think it's 75.
I mean,
75.
yeah. Isn't it 85?
No, it's 75.
No, it's 85.
No, because 75 plus
Yeah,
5
Oh,
is
I
180.
was thinking of 90.
Okay, if this is
I was
90,
right.
then wouldn't it be like 15 degrees past here? 105? Correct? Like 90 plus 10 is 100, plus 5 is 105. So it will be here. Shh, don't talk. This is very important. It's not important, it just occurred to me. So what will be the reference angle here?
85. I mean 75.
75.
Okay. And isn't it true that 15 degrees, this 15 right here, don't lose it, and don't talk, and 75 add up to 90.
What?
So therefore they are complementary. So that is why the cosine of 15 is the same as the sine of 75.
Oh,
Bam.
theory debug.
Co-function, right? Co-function of
Yeah,
everything?
yeah.
Yes.
Right,
Yep.
right.
So that's why we got the same value. Regardless. Was it the same value? Yeah.
It wasn't.
Okay, next. Stop talking. You guys are talking too much. Way too much. Okay. So here we're talking about two angles, according to the problem. We have angle alpha in quadrant 2, and then we have another angle called beta in quadrant 1. So we're going to answer all those questions, but first I want to draw the angles. And I suggest you do the same thing. So for quadrant 2, we're given the sine, and so we know that sine is the opposite over the hypotenuse. In other words, the y over r, the radius. So then the y value is positive 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the hypotenuse, so this is 12, this is angle alpha, hypotenuse is 13. So what will be the adjacent side? This is, it's negative because it's in, we're talking about an x value, right? 5, negative 5. Very good. Now for the other angle, beta, that one is in quadrant 1. And we're again given the opposite in the hypotenuse. So the opposite is like the y over r. The hypotenuse will use r. So then 3, 1, 2, 3. So I'm going to say it's a point like right here. So this is 3. This is 5, the hypotenuse. And what will be the adjacent side? One of those famous triples. 3, 4. Very good, Jeremy. So that is angle beta. Now what we're going to do is answer part A, part B. So what is the cosine of alpha? So we look at our picture, adjacent over hypotenuse. So negative 5 over 13. Let's also write the given information so that you have them here one next to the other. Okay. We're also going to do the same for beta. So cosine of beta is going to be adjacent. Oh, this should be beta. Sorry. Why don't you guys say something?
You don't like us talking.
That only applies to you. Okay. And then, so yes, that was beta. Very important. Don't mix your angles like I did. So cosine of beta is adjacent. Thank you, Tricia. And let's just write the sine of beta. It's already there. It was given to us. And so with that, we can answer now question C and part C and part D. And it's time for your break. So I'm going to pause the video Okay, so we're gonna do part C, and so I want you guys to try it within your table. Look at the formulas and first decide which one to use from 1 to 3, 4. Is it number 1? So formula 1. Now for part D, which formula do you need?
3.
Okay. So within your groups, go ahead and take care of those 2 problems. So what I suggest you do is you first write down your formula and then you proceed to do the substitution. Go ahead. I'm just gonna write the formulas here. You guys are gonna do the substitution. And remember, the ratios are coming from over here. That's why we have all 4 here lined up for you. Don't forget that the cosine alpha is negative. So after doing the substitutions, I'm going to go ahead and multiply fractions. So here I'm going to get negative 20 over 65. Here I would get negative 36 over 65. So that should be equal to negative 76 over, no, I'm sorry, 56, right? 56. Negative 56 over 65. And the last one, so we will have 48 over 65 for multiplying here straight across. Then minus 15 over 65. And 48 minus 15, that's 33 over 65. Yeah. Any questions? We'll give you some time to copy. If you guys have a question, let me know. Okay, so we're almost done. Now for this one, we were supposed to have the graph, but it's okay, we don't need it. We're just going to do that algebraically. So the purpose is to describe this function using another equation. So we're going to refer to the, I believe it's formula 4, the sine of the difference of 2 angles. So instead of sine of x minus 3 pi over 2, what does the formula start with? The formula? Sine or cosine? Sine. Sine? Yeah. So it is sine of the first angle, x, times the cosine of the second angle, 3 pi over 2. And then we need a minus, I believe, and then cosine of the first angle, which is x, and then sine of the second angle, which is 3 pi over 2. Okay, from here, sine of x, we don't know what it is, we just leave it like that. But we do know what is this one equal to, because if you remember the unit circle, 3 pi over 2 is here, and the coordinates of that point are 0, negative. Okay, so what is the cosine of 3 pi over 2?
0.
0, 0. And then minus cosine x, we just leave it there as a variable. And then what is the sine of 3 pi over 2?
Negative 1 side.
Negative.
-1.
Okay, so what is sine x times 0? Just 0. And what is negative cosine x times negative 1?
Cosine of x.
Cos of cosine x. So the graph of cosine x is the same as that graph right there. It's just like the sine graph that shifted 3 pi over 2 units to the right. Okay, now the last problem. Yay! So we have 2 more formulas, 5 and 6. And we're just going to use formula 6 to prove that this identity is true. Okay? So we're going to be substituting using this formula here. So we start with tangent of x minus pi over 4. And so that is equivalent to the tangent of the first angle, which is x, minus the tangent of the second angle, which is pi over 4, over 1 plus tangent of the first angle, which is x in this case, and then times tangent, times because there's no symbol in between them, tangent of the second angle, which is pi over 4. Okay, so here that one stays the same. And then what is tangent of pi over 4? Andrew?
Square root of 2 or 2 over square root of 2, 2 or 1.
There you go. And then on the denominator, we have 1 plus tangent x. And then again, what is tangent of pi over 4? 1.
Don't they cancel out 2 tangents?
No, because
Because you're adding the other thing.
the symbols here. If we have factors, yes. So then what we do is just by the commutative property, since we want it to look exactly like this one, we just switch the order of the terms in the denominator. Okay, and that's it. We're done with the lesson.